about cook that? That's what you're really
Yesterday we looked at the solving systems using substitution. Today we're going to do the exact same kind of problems, but we're going to use elimination.
Can I get the worksheet?
I handed these out a long time ago. They're your notes. Handed them out a long time ago. Okay, now, who remembers anything about the process of elimination? We're solving the same kind of problem, we're going to end up with the same answer, but we're doing it a different way. How does it work, Dave?
You have to make one of those two variables match up to the other but opposite.
Yes, so what he means is we want to be able to add this together and have either the x's go away or the y's go away. Now, if you added right now, nothing cancels out. So in order to do elimination, you usually have to multiply by something. So in this case, if we were to multiply this second equation by 3, do you see what's going to happen here if I multiply by 3? I'm going to have 15x plus 3y equal to 72. And then when I add that to 2x minus 3y equals 13, those are eliminated. That's why we call it elimination. So Gabe was exactly right. We have to have these two numbers, two of the numbers have to match, and one's positive and one's negative, so that when you add them, they will cancel out. Okay, so solve what you have left, which should tell you what your x is. So 17x equals 85. And dividing by 17, does that give me 5? Remember, our answer is an ordered pair. We're looking for where these two lines cross each other. So apparently they cross where the x is 5. Then we'll do exactly what we did yesterday. We take the 5 and plug it back in. And you can plug it in anywhere. It doesn't make any difference where you plug it in. If I plug it in my top equation, putting 5 in for the x, I'll have 10 minus 3y equals 13. Then I will subtract 10. And sometimes we make arithmetic mistakes here, kids. If you subtract 10, you're going to have negative 3y equals 3. Negative 3y, don't lose the negative. So then y ends up equaling negative 1. So your answer is 5, negative 1. In the real world, you can do whatever you want. You can substitute or eliminate, and I'm going to teach you some new methods too. It won't matter. But when we take a test over this, you will have to do a problem with elimination and a problem with substitution. So I want you to know both methods, but then after that, you'll do whatever flips your switch. I happen to be an elimination person. I like to eliminate better.
I'm a big substitution guy.
Right, you are a substitution guy, okay. All right, let's try the next one. The next one is problem 4. Now, simply because the variables are squared does not mean that we do anything any different. We're going to do everything exactly the same way. So look at it and decide, do you want to cancel your x's out, or do you want to cancel your y's out? It doesn't make any difference. Nate says he wants to do the y's, maybe because one of them's already negative. So if he does the y's, then the top equation is going to stay the same. And he's going to have to multiply the bottom equation by 3. Now, I do want you to consciously think about you have to multiply everything by 3, even this number over here. Alright, so here we go. Those cancel just like we planned. So 7x squared equals 7. So x squared equals 1. What does that mean x equals? Be careful. Plus or minus 1. Because when we square root, remember, we have to do plus or minus. So we're going to get 2 ordered pairs. One of them has 1 for x, and one of them has negative 1
So you have to
for
do
x.
solve both those in.
Yep, so now we plug in one at a time, and again, it doesn't make any difference where you put them. I'll go ahead and put them in the top. If I put in 1 into my top original equation, I'm going to get 1 minus 3y squared equals negative 11. So negative 3y squared equals, be careful, I'm subtracting, so it's going to be negative 12. So y squared equals 4.
2.
Be careful.
Plus or minus.
Plus or minus 2. So 1 gave me plus or minus 2. So that actually is 2 ordered pairs. I don't care if you write it that way, but do you recognize that's 1, 2, and 1, negative 2? Right? And then, here, I'm going to get this up. And then, now I got to go back and I have to do exactly the same thing, but I'm going to plug in negative 1. Now, what do you notice when you put in negative 1? Is it going to matter, or is it going to be the same as when I put in positive 1? It's going to be the same, isn't it? Because when you square 1, you get 1, and when you square negative 1, you get 1. So you can go back through and do all this work again, but you don't need to. If I put in negative 1, the exact same thing's going to happen. So I'm going to actually come up with 4 answers to that problem. Now, how in the world did that happen, that I got 4 answers?
That's squared.
Okay, that's part of it, because these shapes are not lines.
No, they need the circle.
Well, this one's an ellipse, so this one looks like this one right here, this equation, and the top one is a hyperbola, it looks like that. So do you understand why we got 4 points of solution?
Yep.
Absolutely. The shapes intersected in 4 spots. Your hand up?
No, straight.
Okay.
It's a parabola.
All right, one more. Number 5. By the way, you don't need to know what those shapes are. I just showed you. You just need to find the points of intersection. Okay.
One bowl.
X plus 3y equals 8. And 2x equals 16 minus 6y. We are doing elimination. This is number 5. We're doing elimination.
Oh, this is gonna work out perfectly.
Things aren't lined up very well, are they?
No.
If you're going to eliminate, you need things lined up. So I'm going to go ahead and move this 6y, so x plus 3y equals 8. And then 2x plus 6y equals 16. Everybody see what I did? I added this over here because if I'm doing elimination, things have to be lined up. All right? You will do negative. You can do negative 2 to the first one. Yep. So all the way across, negative 2. And she did that because she wanted to cancel her x's out. Well, yeah.
That's all of them.
Yeah. to cancel out our X's, it ended up
The R
everything canceled. So we end up with 0 equals 0. It all canceled. Now I want you to think about what happened yesterday. Look at number 6, was it yesterday?
That was no solution.
That one was different than this. That time, when everything canceled out, you were left with like 3 equals 8 or something like that, which is not true. But this time I'm left with 0 equals 0. Is that true?
Yeah.
Yes.
So would this be,
So
is that the origin?
These are the same line.
Oh.
These are the same line. So in other words, if you graphed this equation and you graphed this equation, they would be right on top of each other.
So like in the answer blank, do you want us to write same line?
Yep.
Or you just write 0, 0?
No, you never write 0 equals 0. You write same line, or you can write the actual equation of the line if you'd rather do that. All right, but what I really want you to get, kids, is the difference between what happened yesterday, and I don't remember exactly what it was, but something like 3 equals 8. That is different than 3 equals 3. This is no solutions. This is not true. This is the whole line. Okay? All right. Okay, well that's it for the old stuff. Now we're going to talk about the new stuff, which is going to allow us to solve bigger systems of equations. So all the ones we did there on that top page, we had 2 equations and 2 variables.
Matrix.
But there are situations when we have 3 equations and 3 variables, 8 equations and 8 variables. And we do not want to be doing substitution and elimination with those big systems. It can be done, it just takes forever. So, in order to learn some of these new methods, which are a huge part of finite math, so those of you that think finite might be in your future, you need to pay attention because matrices are a chunk of it. All right, so first of all, what is a matrix? A matrix is a rectangular array of numbers arranged in rows and columns. I absolutely guarantee you when we get around to taking a test over this, one test question is going to be define matrix. The whole chapter is about matrices. You need to know what a matrix is.
So it is like a matrix.
So when you're lying on the beach, have your little note card, matrix, rectangular array of numbers arranged in rows and columns. Okay?
Making my watch screen.
B, dimensions. All right, so let me draw an example of a matrix. We use capital letters to name matrices. I'm going to go ahead and draw a matrix. Actually, I'm going to use the one, no, I want to make up my own. So I'm going to do this, 1, 2, 3, 4, 5, 6. That's a matrix. It's a rectangular array of numbers with rows and columns. The dimensions of this matrix, the dimensions are 2 by 3. And that's the way we say that, 2 by 3. Because it has 2 rows and 3 columns. Dimensions are rows by columns. This is what we mean by the dimensions or the order of the matrix. It's the number of rows by, don't say times, by the number of columns. So if someone were going to carpet this room, they'd come in and measure it, and they'd say it's 20 by 18. You've heard that before. That's how we identify a matrix. It's rows by its columns.
So that picture.
Rows of a bleacher, columns of the White House. We're not going to get those confused. Rows of the bleachers, columns of the White House. So this has 2 rows, 3 columns. Okay? If a matrix has the same number of rows as columns, so if it were a 2 by 2, or a 3 by 3, it is called square, a square matrix. That makes sense, doesn't it? If it has the same number of rows as columns, if this room is 20 by 20, it's a square room. All right, so what's a square matrix? A matrix that has the same number of rows as columns. The numbers in the matrix are called entries or elements. So the numbers inside the matrix are the entries or the elements. When we identify an entry, so let's say I want to talk about this guy right here. I want to talk about that 4. I would refer to him with a lowercase a. That tells me he's in matrix A. I use capital letters for my matrix. So a lowercase a means I'm inside matrix A. And my subscript down here is going to be 2, 1. That means I am the number in matrix A in the second row and the first column. So the second row, first column is 4. So how would I identify the 3? How would I identify that? What would that be? A, 1, 3? Because it is in the first row, third column. Now, when you have multiple matrices, as we do in the next, in our next examples here, you've got to pay attention to the letter here because that tells you which matrix to look in. A scalar. If I put a number out here in front of the matrix, like a coefficient, it is called a scalar. A scalar is simply a real number that multiplies the matrix. It's like the coefficient. We skip chapter 6. The vocabulary, which is vectors, the vocabulary of vectors and matrices is the same, and they have a different language. They use different words, and so instead of saying coefficient, we say scalar. Equal matrices. Any idea what we mean by equal matrices?
The number in the rows, same as the number in the columns.
I think I understand what you're saying. Equal matrices have 2 things, 2 qualities. First of all, they have to have the same dimensions. In other words, if they're going to be equal, they have to be the same size. Doesn't that make sense? 5 by 8 can't equal a 2 by 3. They have to be the same size. And then their corresponding entries have to be equal. Now, what does that mean, Mrs. Ford? Well, think about it for a minute. If I have 2 matrices, and they're going to be equal to each other, they have to be the same size, right? So let's say this one is 1, 2, 3, 4, and this one is 4, 3, 2, 1. Those 2 matrices are not equal. What's wrong? They're the same size, they got the same numbers. What's wrong with it? Why aren't they equal? They're not in the same spot. That's what corresponding means. So whatever's in the 1, 1 spot has to be the same as what's in the 1, 1 spot here. So these would be equal. Now, I know you're thinking, what's the point of that? Well, that's kind of a dumb example. We'll run into a situation where we'll set matrices equal to each other. Okay, so we have our vocabulary under control. We know what a matrix is. We know entries or elements or the numbers inside. We know square matrices have the same dimensions. We know every time we talk about a matrix, we talk about its dimensions. 3 by 4 means 3 rows, 4 columns. Rows are like in the bleachers. Columns are like of the White House, right? Roman Catholic. Rows and then columns, always. So if you see 6 by 8, that means 6 rows and 8 columns. Okay, so what are we going to do with these things? Well, I think the first one you can answer already. Problem 1A says, what are the dimensions of matrix A?
2 by 2.
Exactly. See, you got it already. Matrix A is 2 by 2. It has 2 rows and 2 columns. So it's square. All right, what about B? What are the dimensions of B?
2 by 3.
2 by 3, because it has 2 rows and 3 columns. All right, A sub 2, 1. Now, A sub 2, 1 means in matrix A, second row, first column. So the number is 3. B sub 1, 2. First row, second column. 0. There's your first row. There's your second column. 0. C sub 3, 1.
Can't do it.
Can't do it. Why not?
Not 3 rows.
There's no 3 rows. There's no third row. That's a trick question. You can't do it. All right? Now, C says, take these 2 matrices, A and B, and add them together. We're going to add A and B together. You can't do it. Does anybody have an idea why you can't do it? They're not the same size. If you're going to add them together, they have to have the same dimensions, right? If you started adding, there wouldn't be anything to do with this 3 and 4 over here, right? Because there's nothing matching up. What about A and C, though? Can A and C be added?
Yeah.
All right, so do you have an idea how we would do that?
The top row is 0 and 3,
All right, Nate says the top row would be 0 and 3.
and the bottom row is 7 and -4.
How is he doing that? He's exactly right. Do you see what he's doing?
You add that row.
You add what we call corresponding entries. So add these 2 together, and that's what goes in that spot. Then you add these 2 together, and that's what goes in this spot. Because notice, I'm adding together 2 by 2s, so doesn't it make sense that my answer is going to be a 2 by 2? So to get that spot and get that number, you just add the numbers that are in that spot. So you add 3 and 4. Okay? And to get this number, you add these. It's super easy. They got to be the same size, and you add corresponding entries. All right, what do you think about E? It says 2 times A. 2 is what we call a scalar, so we're taking 2 times A. Anybody have to take a wild guess on that one?
Distribute the 2.
Exactly, you just distribute the 2. So you're multiplying it by A, so the top will be 2, 4, and the bottom will be 6, -8. Look alive, JP, good job. All right, F, 2C minus A. Now, first of all, addition and subtraction have the same rules. You have to be the same size. Am I going to be able to subtract A and C? Is that going to be possible?
Yes.
Yes, because they're the same size. But the C has a 2 in front of it. So I'm going to multiply it. So 2C is going to be -22, 80. Does that make sense to everybody? That's 2C. And now I'm going to subtract A. We're going to do this just like you did the addition, only this time you're subtracting.
-1.
So -2, oh, be careful, -2 minus 1, that's -3. 2 minus 2?
4. No, my
Eight.
bad. I'm going down. I'm already
8
on last one.
minus 3.
What allows me 4 because 2 negatives?
0 minus negative 4 would be positive 4. That's right. So regular arithmetic rules apply, folks. We're doing regular arithmetic. And the last one, at least, yeah, is b minus 2a. What do you think about b minus 2a?
Can't do it.
Can't do it. Very good. There are a lot of things we can't do in matrix algebra because the rules are pretty specific. Does everybody understand why that's a can't do?
It's not the same.
They're not the same size. B and A are not the same size. All right. So now I've got a new set of matrices. And looks like in this section we're multiplying. All right, so here we go. We are going to multiply A, which is on the first page here. Here's A. And now we're going to take it times F. All right, so this is A times F. That's what we're doing now. We're taking A times F. Okay? Now, we got to talk about the rules for multiplication because they are different than the rules for addition and subtraction. Remember that in order to do addition and subtraction, the matrices have to be the same size. So these two could definitely be added, right? They're the same size. The rule for multiplication is this. Write down the dimensions of your two matrices. So this is a 2 by 2, and this one is a 2 by 2. In order to multiply, these two numbers have to match. They do not have to be the same size. The matrices can be different as long as these two numbers match. So in other words, you could have a 3 by 8 and an 8 by 7, and they would multiply. They wouldn't add, but they would multiply. Okay? So when you are going to multiply matrices, the first thing you do is check the dimensions. Do these match? The columns of the first and the rows of the second, do they match? They do. Because they do, I can multiply. And these dimensions give you the size of the answer. So my answer is going to be another 2 by 2. 2 rows, 2 columns. Now in this example I put over here, my answer would be a 3 by 7. Okay? Multiplication is its own animal. These dimensions have to match. These dimensions give you the answer, the size of the answer. Okay? So everybody with me so far? All right. So now I got to start figuring out what goes in here. So I want you to think about this for a second. As you practice more, you won't need to do all these little meticulous steps. But for our first time, you really need to think about this. This number right here is in the 1, 1 spot. That's not an 11. That's a 1, 1. That's first row, first column. This number is in the 1, 2 spot. First row, second column. What's this one?
2, 1.
2, 1. And 2, 2. Now the reason I identified those is because in order to fill that blank, the 1, 1 blank, I take the first row times the first column. First row times first column. So I take 1, 2 times -1, 3. So 1, 2 is my first column, so I write down 1, 2. And then I write down my first column, -1, 3. I multiply this pair and add them together, and that's the number that goes in this spot. So that's -1 plus 6, that number is a 5. It's not 5/11ths, that's not a fraction. I just labeled it so that I would know that's first row, first column. Now, when I step over here, I'm still doing first row, so that's still 1, 2. But now I'm doing second column, which is 5, 0. Right? First row, 1, 2. Second column, 5, 0. Now you multiply each pair and add them up. So that one's also a 5. Again, not a fraction. It's 5. Now, how am I going to do this? Second row, which is 3, -4. And first column, which is -1, 3.
-3 and -12.
So -3 and -12 makes -15. And then finally, second row, which is 3, -4 again, and second column, which is 5, 0. 15? Now I know those numbers match, that's coincidence. Please don't think that's going to happen every time, because it's not. It's a little tricky. Let's try the next one. That was 8 times F. All right, so now I'm going to do F times A. I'm erasing my answer, but you guys have it written down, because I wonder if A times F is going to be the same as F times A.
No.
No?
This is going to change the way it compares. No way.
Jaden's saying no way.
I don't know. I said no wait.
Oh, no wait?
No, it's going to be different.
Okay, Jaden thinks something, I'm not sure what exactly.
It's something.
Yeah, something, just not sure what. All right, so remember when we multiply matrices, the first thing we do is check our dimensions. I kind of did that in my head. Those match, so I'm going to have a 2 by 2 as my answer again. Come on, Nathan, head up. Come on, this is exciting. Here we go. To find this number right here, I'm going to take the first row, -1, 5, times the first column, 1, 3. This is easy, but you have to be organized. So develop a system that works for you. You multiply each pair and add them up, so that first number is a 14. Jaden was right. They're not going to be the same thing. All right. Now, if I do this one, it's still the first row, so it's -1 and 5. But now it's the second column, which is 2 and -4. What is that? -22. All right, now moving on. Second row. So 3, 0. And first column, 1, 3. So that's 3. Oh, is it 3?
Yeah, 3. 0.
And then the last will be 3, 0 times 2, -4. think that one's a 6.
Oh, yeah.
Come on, man.
All right, tell me about DE, the next one, D times E.
No.
What are the dimensions of D? D is a 2 by 2. What are the dimensions of E?
3 by 3.
3 by 3. Is that multipliable?
No.
No. Nope, nope, nope. So C, problem C, is no answer. Is everybody clear on why C is not possible?
Same thing, the next one.
Same thing for the next one? What are the dimensions of D?
Oh, wait, it might be.
D is 1, 1, 3, negative 2. And what are the dimensions of G?
Yeah, the top row is.
G is 1, 2, 3. Negative 3, 1, 0. All right, so this is a 2 by 2. What's this one?
2 by 3.
A 2 by 3. Are they multipliable?
Yeah.
Yeah, they are. And your answer will be another 2 by 3. Could you add these two? Could these be added?
No.
No, but they can be multiplied. All right, so here we go. First spot here. Label it, if it's easier for you, that's first row, first column, first row, second, first row, third, 2, 1, 2, 2, 2, 3. If that confuses you, don't do it. If it helps you, do it. This tells me I'm going to take my first row times my first column. All right? So I'm going to do 2 of these with you, and then you're going to fill in the rest of it. So pay attention if you're confused. First row, write them down. First column, write them down. Multiply each pair and add them up. So, -2. All right, I'll do the next one, which is first row, second column. So that's first row, 1, 1, write them down. Second column, 2, 1. Multiply each pair and add them up. 3. Now, see if you can fill in the rest. See if you can fill in all the rest of those numbers.
How do you know which one is to multiply?
What do you mean? So this, if you've labeled this tells you. You have your first row and your third column. So you write down the first, or write down the first row, there they are, in order. That's the first number, that's the second number. And then my third column, write them down in order, first number and then second number. And then you multiply each pair and add them up. So that's also a 3. So now you're going to the second row. So what are the numbers in the second row?
3, -2.
So I write down 3, -2. What are the numbers in the first column?
1 and -3.
Write them down next
Okay.
to here. And then multiply and add them. So I said I wasn't gonna do mine. I got 9 for that one. Now, you guys do the last 2. You already got them done?
Yes.
Oh,
I got 9.
I got 9.
not sure how you got 7. Let's see. It's second row, so it's 3, -3.
Oh, never mind.
And 1, -3.
I'm riding with Mrs. Ford.
I put 2
I'm riding with your
-2.
answer.
I put 2 -2. I don't know why.
I don't either. So this is the second row. So there's my 3 and -2, and here's my first column. So that's 6 and 3, so that should be a 9. So those of you got 7, you figure out what you did wrong? All right, what'd you get for these spots? 4 and 9? I'm gonna check those, I'm not saying those are right yet. 4 is right, and 9 is right, that's exactly right. Anybody have a question about the 4 and the 9? Nope, okay.
Alright, looks pretty good to me.
Looks pretty good, okay, glad to hear it. That was what? Is that letter D?
Yeah, it was
Okay,
D.
so we have one more to go, we have G times Z, which Kennedy says works because G is a 2 by 3. So we are multiplying 1, 2, 3, negative 3, 1, 0. That's a 2 by 3. That is matrix G times matrix E, which is a 3 by 3. So Kennedy was right when she said that works. It does. It does. How big will my answer be? These match, so that means it works. So my answer will be a 2 by 3.
Thank you.
Which means 2 rows and 3 columns. So 2 rows of the bleachers, 3 columns of the White House. Now, what's different about this one, you're going to do everything the same way. This is 1, 1 right here. So you're going to take your first row times your first column. You just have more numbers this time because your first row is 1, 2, 3. And then you attach your first column, which is 1, 1, negative 1. And you multiply each pair and add them up. So there's just more to keep track of. So what do we have? Is that 0? Yeah. All right, that's easy enough. All right, go ahead and see how far you can get. See if you can fill in all the rest of them. It is easy to make mistakes on this. So it's very possible I've got a mistake somewhere. Especially if you try to go too fast. You can really make a mistake with all the arithmetic. All right, so I've filled them in, so I'm just kind of waiting. You let me know if you agree or disagree. Don't just copy mine down because they could be wrong.
I agree.
What?
I said I agree.
You got them all done already?
You're good at the first row.
Okay, do we match on the first row?
Yeah.
Good. So now you're gonna do the second row the same way, except you're gonna be using these numbers now to start with. Kennedy, do we match?
Yeah.
You and me? Does anybody anybody have a question about a number so far? Anybody not getting something that I got? Leo?
Yeah, I got them all the same except, like, I got it right, the right system, but I accidentally put 3 instead of -3.
It's easy to make arithmetic mistakes. You really have to be careful.
Rookie.
But like he said, there's a system. You got your system now. You know what you're doing. Okay, well, that's pretty easy then. Let's see what's on the next page. Oh, another one. Another one.
No, he just said that was the last one.
F times G. Right? Okay, can we even multiply F times G?
Yes.
Oh, Kennedy says we can. That's such good news.
Oh, we can.
So let's go ahead and multiply. Let's see,
By
F
two or-
times G.
Can you come to what you want? This is Nicholas. These problems.
I love it.
F times G. The reason Kennedy says that we can multiply these is because F is a 2 by 2 and G is a 2 by 3 and these two match. So we'll be looking for another matrix just like this, another 2 by 3. Alright, so this time I'm going to call on people to fill it in. So get busy. We're going to put some pressure on you here to make sure you're paying attention.
That ain't right, Miss
Yeah, I know, how dare a teacher call on a student.
All right, let's do it. What?
How do you look like this one? It's G.
You take, so like you want first row, first column. That's how we multiply. It's rows times columns. Always remember, rows come first in everything. Dimensions, multiplication, everything. Rows come first. Roman Catholic, RC, rows, columns. So sometimes it's helpful to actually circle the rows and circle the columns. Rows are the first, columns are the second. But you'll develop your own system, whatever you do. It's perfectly okay as long as you're getting the right answers. So Courtney, you got an answer to the first one? Can't hear you, what'd you say? Remember, we're taking -1,5 times 1, -3, and we're adding them. So how many of you got -16 for that first spot right there? Perfect, perfect. Lainey, you got the second one?
I'm working on it.
Okay, this one right here, I'm talking about this one right here.
Well, Wayne.
3.
Yep, that's what, goofball up here says, 3, all right. Now what? Let's see, who's next? Katie Shin, you got the last one in the first row here yet? You get this one yet?
Yeah. Give me a sec.
Okay.
-3.
She got -3. Anybody want to agree with that or disagree
I
with
agree.
that?
Sure.
We got a lot of agreement. Good job, good job, good job.
I agree.
Okay, we're moving down to the second row now, so we're gonna be using the 3 and the 0 now.
My book.
All right, so Lindsay, you got this one figured out yet?
3.
Yep, it's a 3 also, I think. Would you agree with that?
Yeah, I agree with that. Oh, this one's easy because it's always gonna be the first one.
And then, let's see, Leo, you got the middle one here?
This is
Leo says 6.
Yeah, Leo.
We agree with Leo?
Leonardo.
Alright. And Leo, what about the very last one? Is it what? Is it 9? I don't know, class, do you think she's right? Is it 9? It is. Very, very, very good. Very good. Alright. We have 3 more minutes. We're gonna learn one more little thing.
No way you're serious.
No.
In 3 minutes?
It's far, we can learn 2, not just 1 more, we can learn 2 more.
Alright. Here
2
we go.
more.
This is actually really good because this section has more problems. So we're going to learn a little of it now, and then when we come back, we'll pick up right here, so we'll have to do a little bit of review work. All right, here we go. Notice the notation is different. When I write a matrix, I use a bracket, right? We've been using brackets all along. This is not a bracket. This looks like absolute value, doesn't it? Now, it's not, but that's what it looks like. This is called a determinant. A determinant. And the value of a determinant is a single number. So this is going to equal a number, like 8 or 5 or -2. To get the number, it's very, very simple. You take 1 times 4 and 3 times 2, and you subtract them. So to find a determinant, and you know you're going to do this when you have these vertical lines, you multiply this diagonal, 1 times 4, you multiply this diagonal, 3 times 2, and you subtract those. So the answer to this problem is -2. -2. So it's this diagonal minus this diagonal. When you write this down, you wrote 1 first. I'm sure you wrote 1 first. So do that diagonal first. Oh, it's your first diagonal, starting with your first number. So it's 4 minus 6. The reason that I'm so paranoid about that is, in my life, in high school, I failed 2 quizzes. One of them was this, because I did it in the wrong order. Make sure you're doing this. I was traumatized, I remember, it was more than 25 years ago. This minus this. Always, and your answer is a single number. You want to know the other quiz I failed? This one's embarrassing.